Welcome back to Space Iceland. Thank you very much for joining us. And do have a look at what we've been streaming this morning and what we're going to be streaming later today and tomorrow. Thank you for your company. We appreciate it. Now, we're going to talk about something that's a growing problem, shall we say. It's it's stuff in space. It's also known as space debris. It's also known as space junk. And, and it's a much more serious problem than a lot of people realize. So, stuff in space, in lower Earth orbit. So, let's go back to in 2007, in January, large weather satellite, a large defunct weather satellite, the Fengun 1C, suddenly disintegrated as it orbited uh, almost 900 kilometers above Earth. Uh, it didn't just disintegrate on its own, it was targeted by an anti-satellite weapon that was deployed by the Chinese military against one of their own satellites, one of their own defunct satellites. So the destruction of Fengun resulted in tens of thousands of pieces of space debris scattered in space. We'll actually probably never know how many of different sizes. So this wasn't an isolated incident. There's been other large satellites that have disintegrated. In 1996, there was a French weather satellite that was broken up by space debris. It was a working satellite hit by space debris. In 2009, an active Iridium communication satellite was hit by, here's the stuff in space. We'll come back to that. So the active Iridium satellite was hit by a defunct Soviet Cosmos satellite. These are rather large satellites, which was in a polar orbit, whereas Iridium satellite was in an equatorial one. And so they met at the crossroads and crashed into one another. And that created a huge ribbon of debris, which spread throughout Earth orbits. There's an average of 12 collisions a year, fairly large 12 collisions, 12 collisions a year that we know about, and there's smaller ones that happen all the time. So according to the European Space Agency, let's go back and get a good old view of what's happening there. According to the European Space Agency, space debris currently numbers more than 36 objects greater than 10 centimeters. So 36,000, not 36, 36,000 objects greater than 10 centimeters. That's a lot of large objects. But that's not the only ones. There's another million objects that are between 1 centimeter and 10 centimeters that are up there. And then, what about the ones less than 1 centimeter? Well, we think that there's 330 million of them orbiting. So this is what it possibly might look like up there. So space debris, space junk, is just another kind of litter that we've created as human beings. So sadly, our littering goes beyond the Earth. But unlike the litter on Earth, space debris orbits the planet at phenomenal speeds. We're talking about faster than 25,000 kilometers per hour. So that is 10 times faster than a bullet. And the risks from fragmentation debris increase all of the time. So near-Earth space is a busy place, and it's only getting more hectic. Now, the first satellite went into space in October 1957. That was the famous Russian Sputnik. Since then, more than around 12,000 satellites have been placed into Earth orbit. About 7,500 of those are still there, according to the European Space Agency in September of this year, 2021. And about 5,000 are still functioning. And they're joined by more than 600 satellites every year. So let's have a little delve into what is actually up there. And it's interesting to think that last year during the pandemic in 2021, when many businesses were struggling, many industries were struggling, economic activity in many places slowed down, the satellite launch business didn't seem to suffer. Almost up until April this year, about 850 satellites were launched, and it's been a record-breaking year. So if you put this into context, of the 12,000 or so objects we put into space, 1/3 of those launches have happened in the last 5 years. Now, part of the reason that it's increased so much is that in the last few years, we have rockets, launches putting multi satellites up into space. So we have the start of the CubeSats. So we have the CubeSats, which allows a large number of satellites to be launched at the same time, whereas traditionally a launch only put one or maybe two satellites up in orbit. You have also Starlink satellites, and I think 72 have been launched recently. No, 172 have been launched recently. And their constellation is now over 1,600. It's phenomenal that what's happening. There's OneWeb that has launched multi-satellites. So different organizations are keeping different records. UNUSA, the UN Office for Outer Space Activity, their records indicate that again, there's around 7,500 satellites in space. And the rest of them, well, what's happened to the rest of them? Ideally, when you put a satellite into space, you want to program it to deorbit and lower its orbit until it gets to the point where Earth gravity grabs that satellite, and it burns up as it re-enters the atmosphere. Or else, if it's large, it fragments and falls into the Pacific Ocean, which is one of the safer places on the planet for it to come down. But various organizations, including the Union of Concerned Scientists, who have an interesting website, they keep a record of Operation Satellites, and their latest update shows that there's many satellites that haven't done this deorbiting, and some of them haven't had a program into them. Others of them have malfunctioned. So what is up there? What of all of these are we looking at? Well, the communication satellites, there's about 1,800 communication satellites, which has increased 50% over this last 18-month period. There's Earth observation satellites. There's more than 900 of those. Again, there's been an increase over the last 18 months of about 2.5–3%. Technology and development satellites, well, there's about 350 of those up there. They've increased, as have the navigational and positioning satellites, about 150 of those. Earth science is the only sector. There's about 20 of those at the moment. They've actually slightly decreased. And then you have all the space science satellites up there, of which there's just over 100. And again, those have increased. So there's a lot of things up there, and some of those satellites, the numbers I've just given you, are multi-purpose as well. You also have really iconic satellites up there. You have things in space, stuff in space, really iconic ones. You have the Hubble Space Telescope, and that's orbiting the Earth at about 550 kilometers above Earth. So there's not just workaday satellites. They're all spectacular, but something like Hubble is particularly spectacular. But other things that you wouldn't even expect. For example, if you there are several companies in the United States that offer to put human remains into orbit, and some of them just go up and down. They go up and they pass the Kármán line and they come back down, suborbital. And I had a look at the prices in case you haven't worked out all the Christmas presents you want to give. You can buy an Earthrise package from one of the companies, which means that you're sending human remains or, which is ashes, or DNA, or just DNA, and that costs, the prices start at $2,500. Earth orbit, the prices start at $5,000. That's a more expensive Christmas present. They're also working on sending, on being able to send human ashes and DNA to crash land on the moon. That's $12,000 and up, $12,000 and up. Or Voyager, I wonder where they got that name, that goes into deep space. Again, very pricey. They haven't worked that one out yet. So I'll let you decide whether or not you want to look into that. So space is now being used by all sorts of companies, all sorts of people for different reasons. And it's always produced colossal statistics. But the calculation, let's just put that aside. Let's think of all the objects we're talking about, which are numerous. We have 7,000 satellites up there right now. But 95% of everything that is circling the Earth in orbit right now is space junk. 95% of it is space debris. And this is what could possibly happen. This is a artist's conception of a collision. So there are protocols that have been agreed by European and North American nations that lower decommissioned satellites. And as we said earlier, it allows for a controlled descent to be burned up on reentry. But alternatively, satellites can also be parked in a satellite graveyard orbit, which is higher than any working satellites, although some of them are there are satellites that are parked at 2,000 kilometers, and then the geo satellites, that are geosynchronous satellites, are much further out. So putting them in a graveyard orbit, again, can be very risky. You want to bring this stuff down. You want to get it out of space. But many of the spacefaring nations, and the Chinese being have not agreed to these protocols. And by the way, those protocols are voluntary. They're not enforceable at present. The Chinese have not agreed to these protocols. They're one particular spacefaring nation. And by the way, if you have any lawyers out there who like space, the whole issue of space law is a fascinating one and requires a whole talk on its own. But space law is something that we're at the beginning of looking at all of the implications. So. It's a mess, and it's getting worse. What is happening? Well, whoops, I'm going the wrong way. There's Cosmos again. Sorry, there's a number of things. So in April of 2018, this device here, which is called the NanoRacks Remove Debris. Now, this was developed in the UK, and it was sent up on one of the cargo mission deliveries to the International Space Station, and it was taken out of the spacecraft and pulled into the International Space Station. Now, this thing alarmed officials at NASA enormously, because this removed debris it was going up as a test, and it was designed to bring stuff out of space. And here they were carrying it on the International Space Station, which has been in orbit since 1999. It's been inhabited continually since the year 2000. At any given point, there's 6 or 7 astronauts and cosmonauts, and so they were extremely worried that removed debris, this looks rather inoffensive as we take this nice photo of it, was going to be up on the ISS. And removed debris were very anxious that any test that they did not want to be the one that brought down the ISS. So after a lot of protocols and a lot of experiments. They deployed it finally, and they let it drift away from the ISS for a month before it went into action. Now, it was a test, and it was there to try out the two things that it carries to grab space debris and lower it. One of them being a titanium harpoon, rather like whaling harpoons, and which we're talking about in Husavik, which was one of the famous whaling towns in the past. Now, Center for Whale Watching, I want to add, and also a Kevlar net. And so they were successfully tested by removed debris, and so that was very good. But again, going back to space law, there's complex legal issues before even a defunct satellite can be grabbed and pulled down to a point where Earth orbit's going to ensure that it burns up. Anything in space remains private property or a sovereign property. So that is a big hurdle that has to be jumped. We need more viable options. Now, launching rockets can be very profitable, but so far there's been very, very little money in cleaning up space. This is increasing, and we've heard a little bit about Skyrora, who are very much involved. They're going into they're looking into this. They're involved in this, but certain objects around Earth have made it so dangerous to put new things, to put more satellites into certain orbits. Now, JAXA, the Japanese Space Agency, has calculated the need to remove about 500 larger objects from orbit, and they've worked out a schedule that has to be done at. But we still don't have anything that can do this. Now, the European Space Agency contracted a company called ClearSpace One. Now, ClearSpace One is a small Swiss company, and this is an artist's impression of what they're going to send up in 2025. Now, you can see it's a real sort of almost James Bond creation. It looks like it's a giant space claw that will grab something, and then it functions rather as a tow truck. It will approach something, grab it, and pull it down. But it's not as straightforward as it would appear in a James Bond film, because the object that it's going to grab is tumbling, and you have to maneuver to match the velocity of the object. You have to slow down the tumbling and then capture it, and then put it in a trajectory where you can bring it down into the atmosphere and ensure that it burns. So until we have all these claws floating around, until all the other possible solutions are up there to help clean up space, what's going on? Well, things are still getting hit. Now, going back to the International Space Station, 2 weeks ago, the astronauts and the cosmonauts were woken up by Houston and by Moscow, telling them to initiate safe haven procedures. Now, safe haven procedures means that they should go into their spacecraft. So the Soyuz for the cosmonauts, and the Dragon for the Americans and the German astronaut that is up there at the moment, the German ESA astronaut. Because what had happened the day before was that a Russian satellite had been targeted to test a new Russian anti-missile device, and that seemed to who exactly in Russia was responsible for it. I don't think we know yet, but what it did is it created a tremendous amount of debris, and some of it was flying towards the International Space Station. And in fact, a spacewalk, the same amount of debris. So the astronauts were woken up. They had to initiate the safe haven procedure, which involves going through the International Space Station. This is something that's as big as a football field. It's the size of a 6-bedroom house, and closing all the hatches between the different modules, and initiating what they call the lifeboat procedures, which involved, after closing all the hatches and hoping that if anything hit, that it would only hit damage part of the ISS, that they got into their spacecraft, which could also have been hit. But they're much smaller than the ISS, and they're a much smaller target, the lifeboat procedures. But just a few months ago, when they were on a spacewalk and they were inspecting, and there are dents and dings all around the International Space Station from debris hitting it of different sizes. The Canadarm, which is the robotic arm designed by the Canadian Space Agency, obviously they were examining that, and they found this hole here that was hit by debris, and it's circled down here with the yellow circle. You can see it. It's not very big, but when you have a small object going 10 times the speed of a bullet, that's what happens. The Canadarm is still functional happily, but earlier this week, a spacewalk had to be canceled because, again, the debris field from this recent Russian anti-missile, the missile test that hit a Russian satellite, the Russian missile that hit a Russian satellite, there was so much debris, they didn't want to put the astronauts out there, because it's one thing to be inside of a spacecraft. It's another thing to be having only the protection of a spacesuit. Even a flake of paint from a satellite that had been hit and scattered could potentially pierce your spacesuit, and the consequences would be fatal, literally. So even these tiny objects have a ballistic force. So human spacewalks around the International Space Station require vigilance, and they require luck. So space science fiction has told us a story about this. There's your stuff in space. That's what the Earth looks like right now. The film Gravity, which is rather good, rather gripping and dramatic, and it has a lot of science fact as well as a lot of science fiction. But this science fiction film, Gravity, illustrated what's known as the Kessler syndrome. Now, a Kessler syndrome is a collision that creates a domino effect that's almost impossible to stop. And if you have a Kessler effect, it can create enough space debris that could knock out most functioning satellites and human spaceflight, like the ISS, which would trigger a chain of catastrophic failures on Earth. I mean, we are dependent. We've talked about the satellites that are up there. We have communication satellites. We have navigation satellites. We have Earth observation satellites. We're all dependent on them. Everything that we do in a normal course of the day will be using some information that comes off satellites. So the Kessler effect was named after a NASA scientist called Donald Kessler. Very interesting man. He's still with us. Read up on him. When he started his theory about how a bit of debris could accumulate and essentially snowball, to be honest, NASA didn't really encourage his research, and he had to really be very persistent and very stubborn. And eventually, they did realize, yes, this is a serious problem. And as Kessler has pointed out, and here we are with the stuff in space, mostly junk, 95% of it. As Kessler has pointed out, the issue is space debris is not unlike climate change issues. And I think this year, when we've just had a COP up in Scotland talking about this and pointing out exactly the extent of the climate change issues we have, we should not forget Donald Kessler, who said a couple of decades ago that unless this generation deals with space debris, it's going to get worse for future generations. But Kessler is optimistic that young scientists, and we have some here, in Husavik, and we have many more out there. Young scientists will come up with a solution, and when you do, it will literally be a growth industry. Young scientists, get to work. We're counting on you. Thanks very much.